Welcome, my dear learners, to today's episode on this very channel. In today's lesson, we shall be looking at the proofs of the laws and properties of logarithms. So these are the laws and properties. Let's go through them one after the other. So we are saying that if you have the logarithm of x multiplied y to the base of a, it is the same as taking the log of x to the base of a plus the log of y to the base of a. That is one of the laws. Let's look at the second law. It says that when you have the logarithm of x divided by y to the base of a, it is the same as taking the logarithm of x to the base of a minus the logarithm of y to the base of a. Let's look at the third law. When you have the logarithm of x raised to the power n, where n is a number, all to the base of a is the same as multiplying the power by the logarithm of x to the base of a. Now the fourth law is what the change of base. So when you have the logarithm of x to the base of a, it is the same as taking the logarithm of x to the base of b and then divided by the logarithm of a to the base of b, the change of base. And then these are the two properties that we'll be looking at. It says that when you have the logarithm of a number to the base of the same number gives you 1. And then we have the other property which says that when you have the logarithm of 1 to the base of any number gives you 0. So these are the laws and properties of logarithm. Let's look at the proofs. So we are starting with the properties because along the line we'll be making use of these properties, improving the laws. So let's start with the first one. So we are saying that, we are starting with this one which says that when you have the logarithm of a number to the base of the same number is equal to 1. Let's look at the proof. So we are saying that now this can be explained as to what power must a be raised to produce a. In other words, a raised to what power will give us what? A. So we can write it mathematically as a raised to what power? We don't know that power, so let x represent that power. Will produce what? A. Another approach is we can decide to equate this to any variable at all, let's say x, and then we convert this to an exponential equation. And doing that, we know that the base of the logarithm will move and become the base of the power. So we are going to have a raised to the power x is equal to a, which will yield you the same answer here. Now at this point, we are having what? An exponential equation, and we know that when the bases are the same, what we do is to equate their exponents. This is the same as a raised to the power 1. So you have x is equal to 1. So from here, you can say that our log of a to the base of a is equal to 1. Now we can apply it in this very form when you have log of 2 to the base of 2. So the number is the same as the base of the logarithm. So let's evaluate this. In other words, let's find the value of this logarithm. So we are going to equate this to any variable at all. Let's say the variable x. Now that we have this, we are going to convert this to an exponential equation. So the base of the logarithm will move and become the base of the index or the power. So you have 2 raised to the power x is equal to what? 2. Now once the bases are the same, what do? We equate their exponents. So that is the reason why we say that when you have the logarithm of a number to the base of the same number is equal to 1. That is one of the properties. Let's look at the next property. So we are also saying that when you have the logarithm of 1 to the base of any number is equal to 0. So let's look at the proof. So we have the logarithm of 1 to the base of any number. Now this is a logarithm number. We can explain it as to what power must a be raised to produce 1. In other words, a raised to what power will produce 1. So we can write it mathematically as a raised to what power? We don't know that power. So let x represent that power. Will give us what? 1. Now remember, in indices, we said that when you have any non-zero number raised to the power 0 gives you 1. So any non-zero number raised to the power 0 gives you 1. So this means that in place of 1, we can substitute a raised to the power 0. Now we are having an exponential equation. Since the bases are equal, we equate their exponent. So we have s is equal to 0. So that is what we have here. You can apply it in this well form. Let's take it that you have log of 1 to the base of 5. Now this can be explained as to what power must 5 be raised to give us 1. In other words, we can equate this to x so that we convert this to an exponential form. So we have 5 raised to the power x is equal to 1. Now we can write 1 in an index form as what? 5 raised to the power 0, because this will give us 1. So you have 5 raised to the power x is equal to 5 raised to the power 0. Since the bases are the same, we equate their exponents. So we can therefore conclude and say that the logarithm of 1 to the base of any number gives you 0. That is the second property. Now let's move on to the laws. So we are starting with the first one, which is this. We are saying that the logarithm of x to the base of a plus the logarithm of y to the base of a is the same as the logarithm of x multiplying y to the base of a. We want to look at the proof of that. So in proving this, we are going to start proving from the left to the right. On the left, we have this. We are proving from the left to the right. On the left, we have this. Now what we will be doing is, we are going to let any variable to represent logarithm of x to the base of a. Then after that, we also assign a variable to represent the logarithm of y to the base of a. So we are letting log of x to the base of a be equal to any variable at all. Let's call it b. Now once we have this, we express this in an exponential form. So the base of the logarithm will become the base of the index. So you have a raised to the power b is equal to x. Now let's call this equation 1. Then we let log of y to the base of a be equal to any variable at all. Let's call it variable c. Then after that, we express this in an exponential form like this. So we are getting a raised to the power c is equal to what? Y. Let's call this equation 2. Now since we are talking about multiplication, let's multiply equation 1 and then equation 2. So we have multiply equation 1 and equation 2. So we'll be having a raised to the power b times a raised to the power c. So we have, and then we have x times y will give us what? xy. Now let's move back and then remind ourselves on indices. So in indices, we said that when you have two or more numbers multiplying, they have the same base. What we do is that we pick one of the base, we add their exponents is equal to xy. We are having an exponential equation. Since the bases are not the same, we can't equate their exponents. Instead, what we do is to take the logarithm on either side of the equal sign. So we are going to take the logarithm of this and then logarithm of that. But the logarithm is going to be a base of a. So we will have, now applying this property, this is going to give us what? 1. So you have b plus c is equal to log of xy to the base of a. Now initially we said that we are letting b is equal to log of x to the base of a, and then c equal to log of y to the base of a. So let's replace them back. So we have b is equal to log of x to the base of a, we have plus, and then our c is log of y to the base of a is equal to log of xy to the base of a. And this is the proof of the first one, as easy as that. Let's look at the next law, which is this one. So we are looking at the second law, which says that when you have the logarithm of x to the base of a minus the logarithm of y to the base of a, it is the same as taking the log of x divided by y to the base of a. So we are going to start proving from the left to the right. So we have our proof. On the left, we have, now we are going to assign variables to represent this and another variable to represent this. So we have, let log of x to the base of a be equal to any variable at all. Let's say the variable v. Now we are going to express this or convert this into an exponential form. So you have a raised to the power b is equal to x. Let's call this equation 1. Now let's log y to the base of a be equal to any variable at all. Let's say the variable c. Let's convert this also to an exponential form. So we shall have a raised to the power c is equal to what? Y. Let's call this equation 2. Now since we are talking about division, let's divide equation 1 and then equation 2. So we have divide equation 1 and equation 2. So we have, what is equation 1? So we have a raised to the power b divided by a raised to the power c. And then we have what? X divided by what? Y. Now applying the division law of indices, which says that when you have two or more numbers dividing, they have the same base. We pick one of the base, so you have a raised to the power b minus what? C, and then we have x divided by y. We are having an exponential equation. Since the bases are not the same, we can't equate their exponent. But what we do instead is to take the logarithm on either side of the equal sign. So we are going to take the logarithm to the base of a on either side of the equation, since we are talking about a. Now applying this property, which says that the logarithm of a number to the base of the same number gives us 1. This is going to give us 1. We are left with what? b minus c is equal to. Now initially we said that we are letting b is equal to log of x to the base of a, and then c to be equal to log of y to the base of a. Let's replace them back. So we have b log of x to the base of a minus log of y to the base of a is equal to log of x divided by y to the base of a. And this is the proof of the second law, as easy as that. Let's look at the third law, which is this one. So we have our second law. We want to prove that the logarithm of x raised to the power n to the base of a is equal to n, which is the power, multiply the logarithm of x to the base of a. We want to prove this particular law. Now, we are going to let any variable to represent this logarithm. So let's say, let b to represent this logarithm. Now, once we have this, we are going to write this in an exponential form. So you have a raised to the power of b is equal to x. Now, since we are talking about powers, let's raise each side of the equal sign to the power of n. So we have to the power of n to the power of n, since we are talking about powers. Good. Now we can write this as a raised to the power bn, applying the power law of indices, and then we can write this as s raised to the power n. Since we are having an exponential equation and the bases are not the same, then we have to take the logarithm on either side of the equal sign, and the logarithm must be to the base of what? A. So we have, now applying this law, this property, you have this to be what? B multiply n is equal to log of. Now initially we said that we are letting b to be equal to log of s to the base of a. So let's replace our logarithm back. So we shall have log of x to the base of a multiplying n is equal to. Now since multiplication is commutative, we can decide to bring the n in front. So we have n is equal to log of s raised to the power n to the base of a. And this is the proof, as easy as that. Let's look at the last law. So we have our last law, which says that when you have the logarithm of x to the base of a, this is called the change of base. Change of base. So we want to look at the proof of that. Let log of x to the base of a be equal to any variable at all. Let's say b. Now from here, we are going to write this in an exponential form. So the base of the logarithm will move and become the base of the exponent. So you have a raised to the power b is equal to x. Now since we are having an exponential equation, the bases are not equal, we can't equate their exponents. So we are going to take the logarithm on either side of the equal sign. But the logarithm that we are going to take must be a different base, since we are talking about change of base. So we are going to introduce a new base. Let's call that base b. So we are going to take the logarithm to the base of b on either side of the equal sign. Now from here, applying this law, the power will come in front so that we can have something of this nature. So from here, the b will come in front. So you have b multiplying log of a to the base of b is equal to log of x to the base of b. Let's divide both sides by log of a to the base of b. So you have our b is equal to. Now initially we said that we are letting b to be equal to log of s to the base of a. So let's bring it back. So we have log of x to the base of a is equal to. And that is that. This is the proof of the change of base law. This brings us to the end of today's lesson. In our next lesson, we shall be looking at the application of these laws and properties. See you tomorrow. Bye bye.